Okay, ladies and gentlemen, if you need a refresher for section 1.3 from Math 1033, let's look at the first problem. So get your class notes out. This is the answer key, but what I'm going to try to do is talk you through the steps. Okay, if I have 2 to the opposite of n power, what you need to remember, when you see a negative exponent, what you need to do is take the reciprocal. So what that basically means is move it from the numerator to the denominator or vice versa. So what we're doing here is the opposite of n as an exponent takes 2 and puts it on the bottom in the denominator and makes it to the n power. So you change the sign. And of course what you do is you have to put a 1 on the top, because if you don't, then you're not even seeing the top. So the 1 is a placeholder for the numerator. All right, let's look at the next example. I have 10 to the m times 10 to the n. Remember what laws of exponents say. Laws of exponents are simply patterns. When you're multiplying and the base is the same, what laws of exponents tell you to do is leave the base the same so the 10 does not change, and you add the powers. That's why the new power becomes m plus n. So remember, when you're looking at laws of exponents, you simply find the pattern that fits that problem. The next example, if I have 7 to the m divided by 7 to the n, when you're dividing, the pattern for laws of exponents says keep the base the same, so that's why the 7 remains, and this time instead of adding the exponents to get the new exponent, you subtract. So that's why the numerator, that's why the new exponent will be what's in the top, which is the m, minus the exponent from the bottom, which is the n. So it's always going to be top minus bottom. To get the new exponent, top exponent minus the bottom exponent. In this next example, 6 to the a raised to the b power, the pattern says when you have a power on the inside and a power on the outside, you leave the base the same, so the 6 remains unchanged. And to get the new exponent, you multiply. So a times b is written as ab, and you really don't need to put the dot. All right, let's move on. Let's scroll on down here to your next page of problems. All right, a couple more negative exponent problems here. 1 over y to the opposite of h. All right, here's the deal. When you see an exponent that has, that has a minus sign, the opposite of, what you do is take reciprocal. So if it starts off in the denominator, you move it to the numerator and you change the sign. So the opposite becomes a plus, and that's how we end up with y to the h. In this next example, AB quantity, that's what the parens mean, raised to the opposite of n power. Okay, my first step in the notes, the opposite of n goes with the a, and the opposite of n also goes with the b. So if you'll notice, the first thing I did is I rewrote the problem without the parens. And then notice how I got my final answer. b to the opposite of n on the bottom, so from the denominator and the numerator you now see b to the n, and analogously a to the opposite of n from the numerator appears now in the denominator as a to the n. Let's see what else we have down here. Okay. Alright, a couple more. This problem is a little tricky because a lot of students get this wrong by telling me the answer is 16. No, we don't want the answer to be 16. And here's the reason. This problem does not say negative 2 to the 4th power. Negative 2 would have to be in parens to be read negative 2. That would be 16 if it was negative 2 to the 4th. But this is the opposite of 2 to the 4th. So in this problem, the first thing you do is 2 to the 4th power, which is 16, and the opposite of that becomes a negative 16. Look at my note. All right, look at the difference between the answers with the parens and without the parens. This next one's a pretty simple problem, remembering your laws of exponents, that anytime you see a quantity raised to the 0 power, other than 0 itself, that's the only exception, and we won't get that tricky with you. 8 to the 0 power is going to turn out to be a 1. All right. Okay. This example, let's follow the rules again. 2 to the negative 3 appears on the moves to the bottom as 2 to the third. 5 to the negative second goes up to the top as 5 squared. When you actually carry it out, 5 squared becomes 25, 2 to the third becomes 8. And we're in great shape now. Okay, oops, I went a little too far. Let me come back with my cursor for you. Alright, and let's go ahead and do this one. 10 over 3 to the negative second power. Notice that the negative 2 as an exponent goes with the 10. Yes, right here. And it also goes with the 3. So that's my first thing I wrote out. And then what we do is we move them. 3 to the negative second becomes 3 to the second on the top. 10 to the negative second from the numerator becomes 10 to the positive second in the denominator, and we end up with the answer 9 over 100. Okay? We'll make another, I'll make another clip for more of section 1.3.